Okay, then I want to get a start on our second document of problems here. This week we're talking about introducing limits. So we're talking about two key ideas in this document, one of which is slope. Slope is an important concept from algebra onward, but we do very different things with it now. The other concept is limits, which we'll be getting into in this document. But this first problem we want to look at is about slope, estimating slope on a curved graph like this one. So it says to use the slopes of UQ, UR, US, and UT to estimate the rate of change of y at the specified value of x. The specified value of x is x equals 5. So when x equals 5, this is the point that we're talking about. That's where the function is when x is 5. The rate of change be how fast this is changing, or what is the slope here. This almost looks straight, and you could estimate the slope in different ways. We're going to estimate it by doing slope at a few of these points, getting closer to it. So the first one is UQ. We got answer choices down here, so it must be one of these, and only one of them's kind of closed visually. So you can kind of see where we're headed. But let's see what happens to do some calculations on some of these other slopes. So when it says UQ, we're talking about a straight line that goes through point U and point Q. So I guess straight edge here, and I'm going to mark that in. What we're finding the slope of is this, by the good old slope formula. Coordinates here are 5, 5. Coordinates of Q are 1, yeah, that looks like about 0.2 maybe. All right, so we're just estimating. We'll use those. Slope formula, of course, is y2 minus y1 over x2 minus x1. These are the function values or outputs. But that's 5 minus 0.2. And the x values, that's 5 minus 1. And so I got 4.8 over 4, or about 1.2 is the slope of that one. And we're going to do the same thing with a few of these others, and I think you'll see it's reasonable if you get closer and closer to the point itself, it'll be a better estimate of what's happening around here. This is the average rate of change from here to there, but it looks like it's obviously curving and getting steeper here, so we would expect a bigger number when we get closer to it. Let's do UR. I'll draw it. Coordinates of R are 2, now this looks more like 0.8. So let's see what we get with those figures. Still 5 minus, now it's 0.8. 5 minus 2. We got 4.2 over 3, which comes out to 1.4. So we are getting higher. That is a steeper slope. That goes with what we see in the picture. So we're doing some numerical stuff, tying it to what we see graphically, and trying to get at a concept right here. I'm going to skip US and jump right to UT just to save a little time here. You check the others, but let's see the trend that's going on here. UT is a little steeper yet. That's 4, 3.2. So I got 5 minus 3.2 over 5 minus 4. That's the x values. We got, not 0, we got 1.8 over 1. It's 1.8. So we do see this is getting closer to something here. In UT, that's a pretty good picture of what's happening at U. That's pretty close to the slope there. And I think you could see with this kind of curve that if we kept getting closer and closer, this would keep creeping up the way we're seeing it do numerically here. Getting closer to this, looks like 2 would be a good estimate of what the slope is at that point.